When a common water line exists between two electrically connected buildings, it can serve as a parallel path for current, potentially creating a shock hazard. To address this, bonding is crucial. The National Electrical Code, specifically Article 250, outlines the necessary requirements. Metal water piping systems must be bonded at the service entrance of each building and at every point where the piping enters or exits the building. The bonding jumper should be sized in accordance with Table 250.122. To prevent current flow through the water piping, insulated grounding bushings are essential at the points where metal water pipes enter the buildings. Here's a step-by-step procedure to ensure safety. Firstly, install a grounding system at both the house and the garage, ensuring it meets NEC standards. This typically involves driving grounding rods and connecting them to the electrical system. Secondly, bond the metal water piping systems in both buildings at the service entrance of each building and at the locations where the piping enters or leaves each building. Thirdly, install insulated grounding bushings in the metal water piping systems where they enter both the house and the garage. Fourthly, isolate the neutral and ground conductors at the garage subfeed panel. This can be achieved using an isolating transformer or by installing a main bonding jumper at the service entrance and then removing it at the subfeed panel. The rationale behind bonding water lines is to ensure that any fault current in the electrical system also flows through the water piping, which provides a low impedance path to ground. This significantly reduces the risk of electric shock, as the fault current will prefer the low impedance path of the water pipe to ground rather than traveling through a person. Isolating the neutral and ground to the garage prevents current from flowing on the neutral conductor back to the house service entrance via the water piping. This is vital because if the water piping is not properly bonded, the neutral conductor could become energized, posing a shock hazard. It's important to select the correct size of grounding and bonding conductors. Refer to NEC Table 250.122 to determine the appropriate size based on the size of the ungrounded conductors. Proper installation of grounding electrodes is critical. Grounding electrodes, such as ground rods, must meet specific requirements for depth and spacing. Typically, ground rods should be at least 8 feet in length and driven into the ground so that at least 8 feet is in contact with the soil. If multiple ground rods are used, they should be spaced at least 6 feet apart. When bonding the water piping, ensure the bonding jumpers are securely connected to the piping and the grounding electrode system. Use appropriate connectors listed for grounding and bonding. Insulated grounding bushings are designed to prevent current from flowing through the metal water piping. Install them correctly where the water pipes enter the building to interrupt any potential current path. When isolating the neutral and ground at the subfeed panel, verify that the neutral conductor is properly isolated from the panel enclosure and grounding system. The only connection between the neutral and ground should be at the main service entrance. Regularly inspect the grounding and bonding system to ensure all connections are secure and free from corrosion. Grounding and bonding conductors should be protected from physical damage. If any damage is observed, repairs should be made promptly. Any modifications or additions to the electrical system should be done in accordance with the latest edition of the NEC. This includes ensuring that all grounding and bonding requirements are met. If you are unsure about any aspect of the installation, consult with a qualified electrician. Electrical work should only be performed by individuals with the necessary knowledge and skills to ensure safety. When dealing with common water lines, there is a heightened risk of galvanic corrosion. This occurs when dissimilar metals are connected in the presence of an electrolyte such as water, leading to corrosion of one of the metals. To mitigate galvanic corrosion, consider using dielectric unions or fittings at the connections between different types of metal piping. These fittings electrically isolate the different metals, reducing the potential for corrosion. Also, ensure that all bonding connections are made with compatible metals to minimize the risk of corrosion at the connections. Another measure to reduce the risk of corrosion is to apply a corrosion-inhibiting compound to all bonding connections. This compound helps to protect the metal surfaces from moisture and other corrosive elements. It is essential to use a compound that is specifically designed for electrical connections and is compatible with the metals being joined. When installing grounding and bonding conductors, avoid creating sharp bends or kinks in the conductors. Sharp bends can increase the impedance of the conductor and reduce its effectiveness. Instead, use smooth, gradual bends to maintain the conductor's integrity. When connecting bonding jumpers to metal water piping, ensure that the connection is made to a clean, bare metal surface. Remove any paint, rust, or other coatings that could interfere with the connection. Use a wire brush or other abrasive tool to clean the surface before making the connection. Also, make sure that the connection is mechanically secure and will not loosen over time. Use appropriate hardware, such as star washers and lock nuts, to ensure a tight and reliable connection. It is important to document the grounding and bonding system for future reference. Keep a record of the location of all grounding electrodes, bonding connections, and insulated bushings. This information can be helpful for troubleshooting and maintenance purposes. Additionally, consider creating a diagram of the grounding and bonding system to provide a visual representation of the connections. This diagram can be especially useful for identifying potential problems or making modifications to the system. If the water piping system is used as a grounding electrode, it is important to ensure that the piping is continuous and electrically conductive throughout its length. Any breaks or discontinuities in the piping can compromise the effectiveness of the grounding system. If there are any non-conductive sections of piping, such as plastic or rubber couplings, they must be bypassed with bonding jumpers to maintain electrical continuity. When installing grounding electrodes, it is important to consider the soil conditions. The effectiveness of a grounding electrode depends on the conductivity of the surrounding soil. If the soil is dry or rocky, it may be necessary to use multiple grounding electrodes or to treat the soil to improve its conductivity. Soil treatment can involve adding water, salt, or other conductive materials to the soil around the grounding electrode. The goal is to reduce the resistance of the soil and improve the grounding electrode's ability to dissipate fault current. Also, ensure that the grounding electrodes are installed in locations where they will not be disturbed by excavation or other construction activities. If the grounding electrodes are located in areas that are subject to heavy traffic, they should be protected by concrete or other barriers to prevent damage. When bonding metal water piping, it is important to consider the potential for stray current. Stray current is current that flows through unintended paths, such as metal water piping, due to faulty wiring or other electrical problems. Stray current can cause corrosion of the piping and can also pose a shock hazard. To mitigate the risk of stray current, ensure that all electrical wiring is properly installed and maintained. Regularly inspect the wiring for signs of damage or deterioration. If stray current is suspected, consult with a qualified electrician to identify and correct the source of the current. When installing insulated grounding bushings, ensure that they are properly sized for the diameter of the water piping. The bushing should fit snugly around the pipe and should provide a secure electrical connection to the grounding system. Also, make sure that the bushing is installed in a location where it will not be exposed to moisture or other corrosive elements. If the bushing is exposed to moisture, it can corrode and lose its effectiveness. When isolating the neutral and ground at the subfeed panel, it is important to ensure that the neutral conductor is properly insulated from the panel enclosure. Use insulated bushings or other insulating materials to prevent the neutral conductor from coming into contact with the metal enclosure. Also, make sure that the grounding conductor is securely connected to the panel enclosure and to the grounding electrode system. The grounding conductor should be sized in accordance with the NEC Table 250.122. When working on electrical systems, it is important to take appropriate safety precautions. Always disconnect the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. Also, be aware of the potential hazards of electricity and take steps to avoid them. If you are not comfortable working on electrical systems, consult with a qualified electrician. When bonding metal water piping, it is important to consider the potential for electrolysis. Electrolysis is the process of using electricity to drive a non-spontaneous chemical reaction. In the context of metal water piping, electrolysis can occur when direct current flows through the piping, causing corrosion of the metal. To mitigate the risk of electrolysis, avoid using direct current electrical systems in areas where metal water piping is present. If direct current systems are necessary, ensure that they are properly grounded and bonded to prevent stray current from flowing through the piping. When installing grounding electrodes, it is important to consider the potential for lightning strikes. Lightning strikes can cause severe damage to electrical systems and can also pose a fire hazard. To protect against lightning strikes, install lightning protection systems in accordance with NEC Article 250.60 and 250.160. Lightning protection systems typically consist of lightning rods, grounding conductors, and surge protective devices. The lightning rods are designed to intercept lightning strikes and safely conduct the current to ground. The grounding conductors provide a low impedance path for the lightning current to flow to ground. The surge protective devices protect electrical equipment from voltage surges caused by lightning strikes. When bonding metal water piping, it is important to consider the potential for static electricity. Static electricity can build up on metal surfaces due to friction or other causes. If the static electricity discharges through a person, it can cause a shock. To mitigate the risk of static electricity, ground all metal surfaces that are likely to accumulate static charge. This can be done by bonding the metal surfaces to the grounding electrode system. Also, consider using anti-static sprays or coatings to reduce the buildup of static charge. When isolating the neutral and ground at the subfeed panel, it is important to consider the potential for ground loops. A ground loop is a condition in which there are multiple paths for ground current to flow, creating a circulating current that can cause noise and interference in electrical systems. To avoid ground loops, ensure that there is only one connection between the neutral and ground at the main service entrance. All other grounding connections should be made directly to the grounding electrode system. Also, consider using isolated ground receptacles for sensitive electronic equipment. Isolated ground receptacles have a separate grounding conductor that is not connected to the building's grounding system. This helps to prevent noise and interference from ground loops. When working on electrical systems in wet or damp locations, it is important to take extra precautions to prevent electric shock. Use ground fault circuit interrupters, or GFCIs, to protect circuits in wet or damp locations. GFCIs are designed to detect small amounts of current leakage and quickly shut off the power to prevent electric shock. Also, wear rubber gloves and boots to insulate yourself from the ground. Avoid touching any metal surfaces while working on electrical systems in wet or damp locations. When bonding metal water piping, it is important to consider the potential for corrosion caused by dissimilar metals. When two different metals are in contact in the presence of an electrolyte, such as water, one of the metals will corrode more quickly than the other. This is known as galvanic corrosion. To prevent galvanic corrosion, use compatible metals for all bonding connections. For example, use copper bonding jumpers with copper water piping. If it is necessary to use dissimilar metals, use a dielectric union or fitting to electrically isolate the metals. A dielectric union or fitting is a type of connector that has an insulating material between the two metal parts. This prevents the flow of electrical current between the metals and reduces the risk of galvanic corrosion. When installing grounding electrodes, it is important to consider the potential for interference with underground utilities. Before driving grounding rods, contact the local utility companies to locate any underground utilities in the area. Avoid driving grounding rods near underground utilities to prevent damage. If it is necessary to install grounding rods near underground utilities, use caution and dig by hand to avoid damaging the utilities. When isolating the neutral and ground at the subfeed panel, it is important to consider the potential for voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or fail. To minimize voltage drop, use conductors that are large enough to carry the current load. Also, keep the length of the conductors as short as possible. The National Electrical Code provides guidelines for calculating voltage drop and selecting appropriate conductor sizes. When working on electrical systems, it is important to follow all applicable safety codes and regulations. The National Electrical Code is a comprehensive set of standards for electrical installations. The NEC is updated every 3 years and is widely adopted by state and local governments. Follow the NEC and any other applicable codes and regulations to ensure a safe and compliant electrical installation. When bonding metal water piping, it is important to consider the potential for fire hazards. If a fault occurs in an electrical system, the fault current can flow through the metal water piping, causing it to overheat and potentially start a fire. To prevent fire hazards, ensure that all bonding connections are tight and secure. Also, use bonding jumpers that are large enough to carry the fault current. The National Electrical Code provides guidelines for sizing bonding jumpers. When installing grounding electrodes, it is important to consider the potential for environmental contamination. Some grounding electrodes contain materials that can leach into the soil and contaminate the groundwater. To prevent environmental contamination, use grounding electrodes that are made from environmentally friendly materials. Also, dispose of used grounding electrodes properly. Contact the local Environmental Protection Agency for information on proper disposal methods. When isolating the neutral and ground at the subfeed panel, it is important to consider the potential for harmonics. Harmonics are distortions of the electrical waveform that can cause problems with electrical equipment. Harmonics can be caused by nonlinear loads such as electronic devices and adjustable speed drives. To mitigate the effects of harmonics, use harmonic filters to reduce the harmonic content of the electrical system. Also, ensure that the electrical system is properly grounded and bonded to provide a low impedance path for harmonic currents to flow to ground. When working on electrical systems, it is important to have a qualified electrician inspect the work to ensure that it is done safely and correctly. A qualified electrician has the knowledge and experience to identify potential hazards and ensure that the electrical installation meets all applicable codes and regulations. Also, a qualified electrician can provide guidance on the selection of appropriate electrical equipment and materials. When bonding metal water piping, it is important to consider the potential for water damage. If a water pipe breaks, the water can cause damage to electrical equipment and can also create a shock hazard. To prevent water damage, install water leak detectors near electrical equipment. Also, ensure that all electrical equipment is properly grounded and bonded to provide a low impedance path for fault current to flow to ground in the event of a water leak. When installing grounding electrodes, it is important to consider the potential for theft. Grounding electrodes, especially copper grounding rods, can be valuable and may be stolen. To prevent theft, install grounding electrodes in locations that are not easily accessible. Also, consider using grounding electrodes that are made from less valuable materials, such as galvanized steel. When isolating the neutral and ground at the subfeed panel, it is important to consider the potential for electromagnetic interference, or EMI. EMI is unwanted electrical energy that can interfere with the operation of electronic equipment. EMI can be caused by a variety of sources, including electrical wiring, radio transmitters, and electronic devices. To mitigate the effects of EMI, use shielded cables for all electrical wiring. Also, ensure that all electrical equipment is properly grounded and bonded to provide a low impedance path for EMI currents to flow to ground. Also, consider using EMI filters to block unwanted EMI signals. When working on electrical systems, it is important to use the correct tools and equipment. Use tools that are specifically designed for electrical work. Also, use equipment that is in good condition and is properly calibrated. Using the wrong tools or equipment can be dangerous and can damage electrical equipment. When bonding metal water piping, it is important to consider the potential for vandalism. Bonding jumpers and other electrical equipment can be vandalized, creating a safety hazard. To prevent vandalism, install electrical equipment in locations that are not easily accessible. Also, consider using tamper-resistant hardware to secure electrical equipment. When installing grounding electrodes, it is important to consider the potential for soil erosion. Soil erosion can undermine the stability of grounding electrodes and can reduce their effectiveness. To prevent soil erosion, install grounding electrodes in locations that are not subject to erosion. Also, consider using erosion control measures, such as retaining walls or vegetation, to protect the soil around grounding electrodes. When isolating the neutral and ground at the subfeed panel, it is important to consider the potential for transient voltage surges. Transient voltage surges are short-duration, high-voltage spikes that can damage electrical equipment. Transient voltage surges can be caused by lightning strikes, switching of electrical loads, and other events. To protect against transient voltage surges, use surge protective devices, or SPDs, on all electrical circuits. SPDs are designed to divert transient voltage surges to ground, protecting electrical equipment from damage. By following these guidelines and recommendations, you can ensure a safe and reliable electrical system with proper grounding and bonding, especially when dealing with common water lines between buildings.